Dear students, welcome back to the video classes of Engineering Mechanics. Hope all of you have gone through yesterday's video and studied the topic well. Today, we'll see how to determine the centroid for composite sections. Let's see a problem. Find out the centroid of a T-section shown in the figure. Please draw the figure in your notebooks. So, we are having a T-section in the figure. How to find out the centroid of this T-section? Yesterday, we have studied the centroidal distances of a circular section, triangular section, rectangular section, etc. So, in order to find out the centroid of this T-section, we can convert this T-section into two different parts. So, let's see how will we do this problem. First of all, we are considering the x and y axes as shown in the figure. That is, we are considering the x-axis at the top of the T-section and y-axis at the center of the T-section, such that the y-axis is dividing the entire T-section into two equal halves. Okay, so then what will be the x bar and y bar distances? By looking the figure, we can see that there is no x bar distances. That is, due to symmetry, the centroid lies on the y-axis itself. Then there will not be any x bar distances. Hope you got the concept. That is, x bar is equal to 0. This is because this y-axis is exactly passing through the center of this T-section. Okay. So, now we have to find out the y bar distances. In order to find out the y bar distance, we should divide this section into two parts. That is, we are dividing this section here so that the T-section is converted into two rectangular sections. Then, we can find out the centroid of this rectangular section separately and combine using the equation to find out the net centroidal distance of this T-section. Okay. So, what was the formula used? Y bar is equal to a1 y1 plus a2 y2 whole divided by a1 plus a2. So, let us consider this flange section. This is called the flange and this is called the web of the T-section. So, first of all, let us consider the flange section as section 1. That is a1. So, what is a1? a1 is equal to 12 into 3 and a2 is equal to 10 into 3. So, we got a1 and a2. Now, for the equation, we have to find out the values of y1 and y2. What is y1? Here is our axis. So, y1 will be located at the center of this flange rectangle. That is 3 by 2. So, y1 is equal to 3 by 2 equal to 1.5 centimeters. Then, now we have to find out y2. So, we are cutting the section here. So, this rectangle forms the second section. The midpoint of this rectangle will be located at a distance at the center of this rectangle, that is at a distance of 10 by 2, that is 5. So, it will be located at a distance of 5 centimeter from this point. But we have to find out the distance from our assumed axis. So, that is 3 plus 10 by 2, that is 3 plus 5 equal to 8 centimeters. Now, substitute the values obtained in the equation of y bar and find out the value of the y bar. That is a1 y1 plus a2 y2 whole divided by a1 plus a2 will give you 4.45 centimeters. Clear? Hope you have obtained the same answer. Now, this is the second problem. This will be a homework for you. This is same as the previous question itself. The only difference is that some dimensions are a little bit changing. So, you have to complete this work and submit on the date mentioning in the assignment. So, I'll give you the assignment today itself. Now, let's move on to the next problem. Find out the centroid of I section shown in the figure. First of all, we have to consider the x and y axes conveniently. So, here we are considering the x and y axes such that the y-axis is cutting the entire section into two equal halves and the x-axis is passing through the top of the section. Okay. As in the previous case, due to symmetry, the centroid lies in the x-axis. That is, x bar will be equal to 0. Clear? Now, we have to find out the y bar distance as in the previous case. In order to find out the y bar distance, what was the formula? Y bar is equal to sigma ai yi whole divided by sigma ai. So, first of all, we have to find out the areas of these three sections. So, this I section will be converted into three rectangular portions. This flange will be the first one. This web will be the second portion, and this flange will be the third portion. So, A1 is equal to 10 into 2, A2 is equal to 2 into 15, and A3 is equal to 20 into 2. Now, we have to find out the y distances, that is y1, y2 and y3. So, first of all, y1 is equal to, this is the first rectangle. So, y1 will be located at the center of this portion. So, that is at a distance of 1 centimeter. Then y2. y2 will be located at the midpoint of this rectangular portion. That is 15 by 2. We have to add this 2 centimeter along with 15 by 2 because we have to find out the distance of the centroid from the assumed axis. So, that is y2 is equal to 2 plus 15 by 2. Then y3 is equal to, y3 will be located at the center of this portion, that is 1 centimeter from this point. So, the total y3 distance will be 2 plus 15 plus 2 by 2, that is 18 centimeters. Okay. Now, we can substitute the values in our equation and find out the y bar value. So, let's see another problem. Find out the centroid distance of C section shown in the figure. All the dimensions provided are in mm. Here also we can use the same equations A1, A2, A3 and all. So, as only difference is that we are having a C section. In the previous problem, we were considering an I section. So, first of all, let's consider an axis. So, here where will we consider an axis? It's up to you. Actually, you can consider axis wherever you want. But we'll choose the axis in the most simplest way so that we can do the calculations easily. So, the most simplest assumed axis here is as shown in the figure. So, we'll consider this as the first section, this as the second section, and this as the third section. Okay. So, for the first section, A1 is equal to 5 into 5. That is, here the thickness is 5. So, this remaining length will be 10 minus 5 equal to 5. So, A1 is equal to 5 into 5. A2 is equal to 15 into 5. And A3 is equal to 5 into 5. Clear? Then, now we have to find out the y distances. So, first of all, for the first section, y is equal to 5 by 2. For the second section, this is the second section. For the second section, y is equal to 15 by 2. And for the third section, y is equal to 5 by 2. 5 by 2 plus 5 plus 5. Okay. So, y3 is equal to 10 plus 5 by 2. Okay. Now, substitute the obtained values in the equation to obtain the y bar distance. So, by substituting, we will get the y bar distance as 7.5 centimeters. So, here we are not having any symmetry. So, we should also find out the x bar distance also. In order to find out the x bar distance, we need the values of x1, x2 and x3. So, what will be the values? x1 is measured from the y-axis. So, this is the y-axis. So, x1 will be located at the midpoint of this first section, that is 5 by 2. So, the total x1 distance will be 5 plus 5 by 2. Clear? Then, for the second rectangular section, x2 will be equal to 5 by 2. It will be located at the center itself. Then, for x3 is equal to 5 by 2 plus this distance 5. Okay. Now, substituting in the equation, we will get the value as 4.5 centimeters. Now this is another homework for you. This is also similar to the problems we have done in the previous slides. So find out the values and upload in the Google Classroom. This is similar problem, that is a set section. So here we will convert the set section into 3 rectangles and find out the x bar and y bar distances using the equations of sigma ai yi by sigma ai, and y bar is equal to sigma ai xi, x bar is equal to sigma ai xi by sigma ai. Okay, this is also similar, you can do it easily. Now let's see another problem. Don't get worried by seeing a complicated figure. This is also simple. The only difference is that we have got more number of sections here. So find out the centroid of the section shown in the figure. All dimensions given are in all dimensions are given in centimeters. So here we have converted the section into different parts, that is first section, second part, third part and fourth part. Now the figure got simplified because we have converted the irregular section into 2 rectangles and 2 triangles, and we are considering the x and y axes as shown in the diagram. So now we have to calculate the x1, y1, x2, y2, x3, y3 and x4, y4 distances from these x and these y axes. So let's find out. Okay. So x1 is equal to, we have already studied about the triangular section. Where will be the centroid of the triangular section located? For the triangular section, the centroid will be located at a distance of h by 3 from the right angled portion. Is it clear? We have studied the centroid of triangular portion will be located at a distance of b by 3 from the right angle portion. But here we have to find out the distance from the axis considered, that is not at the right angle. So the centroid will be located at a distance of 2 by 3 from this end. But we have to find out the distance from here. So the distance of centroid from this axis will be b minus b by 3, that is 2 by 3b. Okay. So that is 2b by 3, that is 2 by 3 into 2 centimeter will give you 4 by 3. Then x2 is equal to, x2 will be at the center of this rectangular portion, that is at 1 centimeter from this point. So the total x2 distance will be 2 plus 1, that is equal to 3. And x3 will be, here we are having the 90-degree angle here. So the centroid will be located at a distance of 1 by 3b from this point. That is 1 by 3 into 3 centimeter plus 2 plus 2. That is 5 centimeters. Then x4. x4 will be located at the midpoint of this rectangular portion. That is at, here the rectangle is having a length of 4 centimeter. So in between means it will be located at a distance of 2 centimeter from this point. So the net x4 distance will be 2 plus 2 plus 2, that is 6 centimeters. Now we have to find out the y1, y2, y3 and y4. So y1 will be located at a distance of h by 3 from the bottom, and y2 is equal to, here the rectangular portion, so it will be at the midpoint. So this total length is 15 plus 6, that is equal to 21. 21 by 2, that is 10.5. Then for this triangular portion, y2 will be located at a distance of h by 3 from this point. So h by 3 plus this 1 centimeter. That is, this height is here up to here, the total height is 6 centimeter. Then this 1 centimeter. So height of this triangle will be 6 minus 1, 5 centimeter. So it will be located at 5 by 3 plus this 1 centimeter. Okay, that is 8 by 3. Then y4. For y4, it will be located at the half of the height, that is 1 by 2 centimeters from the bottom. And also we have found out the areas. You know the formula for the calculation of area and all. So I am not repeating all this. That is, area of triangular portion is half BH and area for the rectangular portion is B into L. Okay. So substitute in the x bar and y bar equations so that we can obtain the results as x bar is equal to sigma ai xi by sigma ai. We will obtain the result as 3.28 if you substitute all these values correctly in this equation. Okay. Then y bar is equal to sigma ai yi by sigma ai. So if you substitute these values in this equation, we will obtain the value as 7.98. Clear? Now, this is another figure to find out the center of gravity. So this is also a simple figure. The only difference is that we are having a additional circular, semicircular portion attached to this figure. So as usual, we are considering two axes, x and y axes, according to our convenience. So I am considering the axis here. You can see. Then I am naming the three sections as the semicircular section as 1, the rectangular section as 2, and the triangular section as 3. Now find out the area of all these three sections. Area of the semicircle will be pi r square by 2. Area of this rectangle will be length into breadth, and area of this triangle will be half into base into altitude. So now x1 will be equal to, we have already studied that the centroid of the semicircular portion will be located at a distance of 4r by 3 pi from this edge. But here we have to find out the distance from this y-axis. So from y-axis, the centroid will be located at a distance of r minus 4r by 3 pi. Clear? That is r minus 4r minus 3 pi, that's equal to 2.5 minus 4 into 2.5 divided by 3 pi. We will obtain the value as 1.44 centimeters. x2 will be at the center of this rectangular portion, that is 5 centimeters from this end. So the total x2 distance will be 2.5 plus 5, that is 7.5, and x3 will be at the center of this isosceles triangle, that is 2.5 plus 5 plus 2.5. Clear? Similarly, we will find out the y1, y2 and y3 distances. So y1 will be at the center of this semicircular portion, that is, here we are having the total height here is 5 cm because this is the diameter of the circular section. So it will be located at this point. So y1 will be equal to 2.5, y2 will be equal to 5 by 2. This is the total height 5 cm. So y2 is equal to 5 by 2 equal to 2.5. And for the triangular portion, it will be located at a distance of h by 3 from the bottom. That is 5 by 3 plus 5. By substituting the obtained values in the equation, we will obtain the value of x bar. So we got the x bar value as 7.109 centimeters from the left end, that is the axis we have considered at the left end. Then y bar is equal to 3.22 centimeter from the bottom of the figure. So this is another homework for you. This is also a simple figure. Here we can convert this figure into elementary sections, that is we can draw a line here up to here so that it will be converted into a triangular portion here and a rectangular portion at the bottom, and this will be a semicircular portion. So consider axis here, then find out the x bar and y bar distances. Okay. So thank you.